Hey, all, today we are going to talk more about right triangles, and this time we are going to talk about some special right triangles. So there are two of them. The first type of right triangle that we consider a special right triangle is a right triangle that has two 45-degree angles. So in a triangle that's a right triangle, we know it's a right triangle because of that uh, little box there. That means it's 90 degrees. That makes it a right triangle. If one of the angles is 45, the other one is going to be 45 because all three of these must add to 180. And so we get this special 45, 45, 90 right triangle. And so there's something that we know about the 45, 45, 90 right triangle. And so I'm going to draw another one that looks like this. It doesn't have to be perfect. In fact, mine is very not perfect. We know this right triangle has a special relationship between the legs. That means that is that both legs are the same length. So let's pretend they're both 1. They're always going to be the same length. If I made one length 30, the other length would be 30. But we're going to make this as simple as possible. If both of those legs are 1, then the hypotenuse, that side across from the 90, is going to be the square root of 2. And we can show that this is true by using the Pythagorean theorem. But for time's sake, you'll just have to trust me. If you want to see how that works, I can show you in class. So whenever we have a special right triangle, the two legs are going to be the same. And then the hypotenuse is going to be whatever the leg is times the square root of 2. So if you remember this, this is what we would call a reference triangle. If you remember this reference triangle for 45, 45, 90s, you can use proportions to figure out missing pieces. And so we have similar triangles. We know they're similar because they have all the same angles. And back when we did similar triangles, we talked about the angle-angle similarity. And so since we know all the angles are congruent, then we know that these two triangles are similar by angle-angle. So we can set up proportions by the matching sides. And so if I want to find x, I can match it with its side. And it's really easy if you draw the reference triangle in the same orientation as the triangle you're trying to solve. And so I'm going to set up a proportion x over 1. And then I'm going to set up another proportion using a value in this triangle I know. So I know the hypotenuse. So I'm going to match it with the hypotenuse, 8 over root 2, or 8 root 2, and then we'll divide it by that side, root 2. And so we can now solve this proportion. I can do x times root 2, and then 1 times 8 root 2. But what's really nice is I don't actually have to do that in this one. When I divide x by 1, I don't really need that divided by 1. And I can just simplify what we have over here. We've talked in the warm-up about multiplying square roots and dividing square roots. I can divide square root of 2 by square root of 2. Those cancel. And x is 8. That means this side is 8. In a 45, 45, 90 right triangle, both sides are the same length. So if x is 8, then y is also 8. So let's try that again. And these ones take some practice. I like to draw my reference triangle every time, and that way I remember it. I've committed to memory. My two legs I put 1s on, and my hypotenuse is the square root of 2. I like to draw it in the same orientation as this triangle that I am trying to figure out the side lengths. So I'm going to try and figure out m. I can write a proportion m over 1. They match. They're in the same spot as long as I draw my reference triangle the same orientation. And then I'm going to do my hypotenuse over my hypotenuse since I know how long that is. I don't want to use two different variables because then I won't be able to solve. Here again, I have m over 1, so I don't need that divided by 1. Anything divided by 1 is just the same. And then I have 8 over root 2. In order to write this correctly using convention, we will have to do what we call rationalizing. And for time's sake, again, we will work on rationalizing together in class, but for now, we are just going to leave it like this. Eventually, we're going to want to get the square root out of the denominator, but we will talk about how to do that in class together. And so if this leg is 8 over root 2, this leg should be the same, so n is also equal to 8 over root 2. Let me do one more. I'm always going to draw my reference triangle. You can draw it nice and quick. Doesn't have to be perfect. The legs are 1 and 1. Hypotenuse is square root of 2. I'm going to solve for x here first. So I'm going to match x, the hypotenuse, with root 2, the hypotenuse in my reference triangle. I'm going to match this side that I know, the leg, 2 root 2, with the leg in my reference triangle, 1. And I can cross multiply. This time I am going to have to do some cross multiplying. X times 1 is x. 2 root 2 times root 2. And again, we talked about this in the warm-up. I'm going to multiply root 2 times root 2. That gives me root 4. We know what the square root of 4 is. The square root of 4 is 2. So we bring down this 2, and we bring down the square root of 4, which is equal to 2. And there's multiplication in between all of these. So I can multiply those together to get x to be 4. If this part is tricky for you, please do make sure that you ask one of us for help. If I come back over here, if I want to find y, well, y is a leg, 2 root 2 is a leg. They're supposed to be the same, 1 and 1. They're supposed to be the same, and so y should be the same as the leg that we know, 2 square root of 2. So I want you to give this one a try. I'm going to ask you to find x. I'm going to ask you to find y. If you don't know how to put a square root symbol into Edpuzzle, you can just type SQRT and then put whatever number goes in parentheses. We'll know what you mean. So try this one. If you need help, please do ask. So hopefully you got y is equal to square root of 2 and x is equal to 2. If you didn't get one or both of those, please do ask for help before moving on. Our other type of triangle is a 30, 60, 90 right triangle. The relationship between the legs and the hypotenuse are going to be different. If I have a 60-degree angle, I'm always going to have a 30-degree angle. The side across from the 30-degree angle is going to be 1. The side across from the 90-degree angle is going to be 2. And the side across from 60 is going to be root 3. This is our reference triangle. And then we can go about finding missing legs the same way we did with a 45, 45, 90. We can match up what we need to know. So if I want to solve for a, I'm going to do a over root 3. And then I'm going to do this side that I know. This is going to get a little messy, but we can do it. Divided by 2. I can simplify this over here. I can sort of like shove this 3 down and do 3 times 2. So this part becomes 6. And now I can cross multiply. A times 6 is 6a. 4 root 3 times root 3. The more you do these, the more comfortable you get. When I multiply a square root times itself, we're left with just the number that was underneath the square root. So this becomes 4 times 3, which is 12. And then we divide both sides by 6 to get a to be 2. think the reason why people don't like 30, 60, 90s is because we do have to do one more step to find b. So we're going to write another fraction, b over 1. I know a is equal to 2, so I'm going to not deal with this 4 root 3 over 3 again. I'm going to do 2 over root 3. B divided by 1. Whenever you divide by 1, we're just left with what's on top there. And then we have it equal to 2 root 3. Again, we're going to have to take care of this root 3 at some point, but we'll talk about that together. So for now, we can just leave b like that. Let me do one more like this. I'm going to draw my reference triangle. That's a 60. That's a 30. Across from my 30 is 1. My hypotenuse is 2. Across from my 60 is root 3. The more you draw these whenever you do a problem, the more you'll be able to remember these reference triangles. And now I can write some proportions. So let's solve for m first. M matches with my hypotenuse 2. I know this leg is 3. It matches with this leg in my reference triangle. That is 1. When I cross multiply, m times 1 is m. 3 times 2 is 6. And so that means my hypotenuse in this triangle is 6. I can do the same thing for n. N matches with root 3. So I'm going to write a fraction n over root 3. And then I'll use this side again. 3 matches with 1. So 3 divided by 1 again. And again, I can cross multiply. N times 1 is n. 3 times root 3. That's going to give you a decimal. So we want to leave this in simplest radical form. So I'm just going to write them as 3 root 3. There's multiplication in there, even though we won't write it. And that is good enough for that. So I do want you to try one of these. I'm going to have you figure out what x is and what y is. I'll do you a favor and I will write you the reference triangle since this is maybe the one that's a little trickier. You should know how to do these. So if you do a problem that has a 30, 60, 90 right triangle, you should always draw the reference triangle. Same thing with 45, 45, 90. Give these a try. If you need help, as always, please ask. So hopefully you got these answers. If you didn't get one or you didn't get both, that's okay. Please do call one of us over, though, so we can try and fix any mistakes that have happened and perhaps re-explain. If you're good to go, you've asked for help or you got them right, please move on to the practice. There are 3 of each type of triangle. For each problem, you should draw the reference triangle. Don't just look at the reference triangles that you may have drawn before. The more you draw them, the better you commit them to memory and the easier these problems become. So please do try these. When you get stuck, ask for help right away. Don't wait till it's too late.